Okay, I have here a generator. Generates what we know to be electricity. Originally studied in terms of static electricity and so forth back in the 1700s and earlier. And we know through experimentation and a lot of investigation that was done in the late, I said 17th century, 18th century, in the late 18th and early 19th centuries, that what we get when we crank the generator here is of the same nature. Okay, well, yeah, that's just a little historical perspective. We've got a strip of aluminum here over a pretty strong ceramic magnet. Now, when I crank the generator, the current is going to go through the aluminum. Okay, and we know that that current is the result of a drift of electrons throughout the aluminum. Okay, throughout the aluminum strip. Now, if I crank in one direction, we see that the strip is deflected this way. If I crank in the opposite direction, the strip is deflected this way. So I can deflect the strip to the left and to, well, this way and this way. Okay. Now the important directions here are the direction of the magnetic field, which is essentially upward. Okay, essentially away from the face of the magnet. And we can tell that by just dropping things or bringing the magnet close to things. We can tell that there's a magnetic field in the direction perpendicular to the face of the magnet. The drift of electrons has to be along the aluminum strip, which is in this direction, so that we have a magnetic field that's in this direction or this direction. We don't know which. I haven't tested it. I don't know what the polarity of this generator is, although I could easily figure it out. And it doesn't matter for this demonstration. So, magnetic field along, let's say, a z-axis perpendicular to the plane of this bench top. A current, a drift of electrons in a direction this way or this way, depending on which way I crank the generator, so that the direction of the flow of current is perpendicular to the magnetic field. The force exerted on the aluminum strip is perpendicular to both of those. So it's like we have a z-axis and, let's say, an x-axis and a y-axis. When the magnetic field is along the z-axis and the current is along the x-axis, the force exerted on the current is in the direction of the positive or negative y-axis, depending again on the direction in which the current flows.